Welcome to another episode on circuit network analysis. In today's video, we're going to look at some problems on Ohm's law and resistive circuit. Don't forget to like and subscribe. So let's get started. In our previous video, we discussed about Ohm's law and resistive circuit. We were able to, analyze the relationship between Ohm's law and resistors and how they connect and how they are able to help us understand how resistive network work. In today's video, we are going to do some little exercise on some problems in order to understand properly how resistive circuit work. So let's get started. Here's a question. The first question, question number 1. The question says, find the equivalent resistance of the circuit shown below. Now look at this circuit. The first circuit here is a circuit, just a 3 volt supply with 4 ohm resistors connected to 6 ohm resistors. Now I want you to think about this. Now these resistors, are they connected in series or in parallel? Now you can see, let's check the movement of current. Did the current ever split as it moves? You will be able to tell me that as we move this way, the current didn't split. The current continues to flow along this clockwise direction. So the question there was, find the equivalent resistance. So from that, we can be able to discover that these resistors are in series. So when resistors are in series, what did Ohm's law tell us to do in order to find the equivalent resistors? You simply do what? Add. So to find the equivalent resistor, we are going to say resistor equivalent is going to be the first resistor. Let me just label this resistor as R1 and this as R2. Because they are in series, the equivalent resistance is going to be R1 plus R2. And when we add that up, we can see that the equivalent resistance is simply 4 plus 6, and that gives me 10 ohms. Now, that is very simple, and that's the final answer. Just find the equivalent resistance, no big deal, just find the total resistance. But there is a subordinate question below it that says, also determine the current flow, I. See this current, we want to know what the value is. Now, Ohm's law said that the voltage is equal to the current times resistance. And when we implement that, we can see that we've already gotten our equivalent resistance, which is R equivalent, and that is this. So to find the current is going to be the voltage over the resistor. So when we do that, we can simply do what? What is the resistor we are dealing with? The resistor equivalent resistor, which is the total resistance. You can simply call it equivalent resistance, or you can call it the total resistance. So that current will now be I equal to, what's our voltage is 3 volts. 3 divided by the total resistance, which is 10, and we have the answer to be 0.3 ampere, and that is the final answer. So let's try out the second problem with us to find the equivalent resistance of this circuit here. So let's take a closer look at this circuit and find the equivalent resistance. Feel free to pause the video and try it out yourself. Now, when you have a circuit that comprises of more than two resistors, now in the sense that you have this circuit comprising of resistors that are in series and the ones that are in parallel, you simply need to be careful while handling this type of resistance in order not to make the mistake of superimposing them. So let's get down to work. Now notice something here. You always start with the known, the words that you know very well, with the unknown. So let's get started. Now if I decide to move this way, it's going to be a little bit difficult because I can see that this one is splitting into two. I will say that these two resistors are in parallel with this guy, so it's going to be a little difficult if I decide to move from this direction. But let's try to come from this direction. If we try to come from this direction, let's see what happens here. We can see that this is 12 volt and 8 ohm. Sorry, 12 ohms and 8 ohm resistors. Are they in series or in parallel? Previously, they are in parallel. And we know what Ohm's law said about resistors in parallel. So we are going to solve these two resistors that are in parallel separately to find the equivalent resistance of these two first. So when we do that, when we solve the two resistors that are in parallel, what will be our answer? We will get it that when two resistors are in parallel, you simply apply that formula that says that the total resistance is going to be the first resistors R1 times the second resistor all over R1 plus R2. So when we do that, the resistor, let's just call this resistor R4, so that it's going to be equal to, what's my R1? 8 multiplied by what? 12, and divided by what? 8 plus 12. And when we punch this out on our calculator, we have our answer to be equal to 96 all over what? 20. And when we point that out on the calculator, we have our answer to be equal to 4.8 ohm. So now that is the equivalent resistance, 4.8 ohm. So I can replace the whole of this with just 4 points. Let's put the resistor here, and we just replace it with what? 4.8 ohm. So this resistor, the whole of this resistor is just 4.8 ohm here. So what are we going to do now? Now we've seen that we have reduced these two resistors to just one equivalent resistance of about 4.8 ohm. Now this 4.8 ohm is in what? Is it in series or in parallel with which one here? So let's check it out. Let's check the connection of this guy and this one and see what we have. So we can see that this 4.8 ohm here is in series with this 5 ohm resistor. So let's deal with these two first. Let's deal with these two again. So we're going to take these two and find its equivalent resistance. Why? Because both, they are connected ends to end. So the end of this guy is connected to the end of this one, and it's connected here, and we also have this one coming here. So we can see that these two are in series. So we can add them up. When we add them up, we'll have the equivalent resistance to be 5 ohm plus. So we simply, you know what we do when we have resistors that are in series, we simply add them up. So when we add it up, we have that 5 ohm, the equivalent resistor. Let's call this R5, and that is equal to 5 plus 4.8, and that will give me 9.8 ohm. 9.8 ohm. This is the resistance of these two, the equivalent resistance of these two resistors that are in series. So currently now we now have this bunch of circuit now reduced down to what? To simple circuit like this. We have it like this. Where this one is the R5 that we just got to be 9.8 ohm after reduction of the whole of these resistors up to this point. Now we now have the 6 ohm that is left. So how do we now find the total, which is the equivalent resistance, which is probably the final resistance that we're looking for? To do that, we can see that these two are now in parallel. So you simply apply the parallel rule and just find that out. You can see that the array equivalent is going to be now the 6 ohm, like we said, 6 ohm multiplied by what? 9.8 all divided by 6 plus 9.8. Remember that useful formula that we have implemented. So when we do that out and punch that out on a calculator, we have 58.8 divided by 15.8, and when we punch that out on the calculator, our final answer will be equal to 3.72 ohms, and that is the equivalent resistance of these whole resistors. Remember, the process that we use is simply the reduction formula, which enable us to be able to break the circuits, the resistance down using the knowledge on resistors in series and resistors in parallel as obtained from Ohm's law in order to get our final answer. You can't just jump into resistors that are connected like that. We call it the complex resistance. We can't just jump into it and start calculating because they are not in series, they are not in parallel, they has the mix up of both. So it is important to use the reduction formula to break it down into the areas in such a way that you'll be able to analyze them differently using the knowledge of resistors in series and that of parallel. So let's move down to the next question, which I would like you to try out. Feel free to pause the video and try this question out. So here's the question number 2. It says, find the current flowing in the circuit below and the equivalent resistance. So what is the circuit? Here is the circuit. Wow, this circuit might really look a little bit complex. I want you to feel free to pause the video and implement the strategy that we used in solving this problem into this guy. So if you are able to implement it properly, you will get the final answer straight away. So let's get started. Notice that we are asked to find the current flowing in the circuit and the equivalent resistance. So we are going to start with the resistance first. So when we get the equivalent resistance, to find the current, we just implement this Ohm's law and we're good to go. So let's implement. This is a very simple problem. So let's quickly get down to work. Now, to solve these problems, I want you to just imagine this. Let's start with the part that we know. It's always interesting to start with the last part, which is the left part, the part containing where the resistors tends to come to an end. You start with from the end to part where the source voltage is. So to do that, let's quickly go there to work. So we can see that 4 kilo ohm resistor is in series with 2 kilo ohm resistor. So to get the equivalent resistance of these two, so we just solve these two first and get the equivalent resistance. What would the equivalent resistance looks like? We can see that it's just series, and series resistance can tell us, let's just call it R1. So we can call it R1 will be equal to 2 kilo ohm plus 4 kilo ohm because they are in series. So we just add that up, we have 6 kilo ohm resistors, and that is what these two guys add up to be. So we can just put it down here. We can put it here. That's the equivalent resistors, which is what? Which is 6 kilo ohm resistor. So that is these two guys that have been connected. We solved these two up. Now we are moving, we are coming close. So we now take the answer that we got from these two and check the next one. The next one, you can see that 6 kilo ohm resistor and 3 kilo ohm resistors are in parallel because they're connected. The two ends are joined together here at the same time here. So what did Ohm's law say about two resistors that are in parallel? There's a formula for that. We simply implement that formula and we will get what let's just call it R2. So when we call it R2, we will just get it that R2 will be equal to 6 multiplied by 3 divided by what? 6 plus 3. And 6 times 3, we have it to be 18 divided by 6 plus 3, which is 9. And when we divide these two guys, we have our answer to be 2 ohm. And that is what we have here. So we have this to be 2 kilo ohm, and this is the equivalent resistance of these two resistors. So you can actually replace the whole of these resistors here, from here to here, with just what? With just a 2 kilo ohm resistor. Does that make sense? You can understand the angle that we're coming from. So when we can replace the whole of this with just 2 kilo ohm resistors. Now you can see that these 2 kilo ohm resistors is just connected this way, like this. You just have your 2 kilo ohm resistor here. And you know that this 2 kilo ohm resistor is connected in series with this guy here. So we can simply add it up. So when we add it up, we can see 2 plus 10. We call it R3, and we have it at 2 kilo ohm resistor plus 10, and we just have 12 kilo ohm resistor. And that is what these two resistors here, which is the total resistance of the equivalent, and this guy here will give you. This two is 12 kilo ohms. Now, how does the circuit now look? So I can redraw the circuit. I will be having something like this for now. We have this. Here is 48 volts. Here is my 2 kilo ohm resistor. Here is my 4 kilo ohm resistor. And here is the arrow equivalent. And I have a resistor here. That resistor here is 6 kilo ohm resistor, and this is the one that I'll be solving, which is the arrow 3, which is what, 12 kilo ohms. So now it means that the whole of this has been summed up to what, 12 kilo ohms. So let's quickly know what to do next. The next thing to do is to just these two are in parallel. We simply implement the parallel rule and solve these two resistors that are in parallel. So what do we do? Remember, even without mixing words, you can see that this resistor, and this resistor, they are all in parallel. So let's quickly solve the three of them at the same time and see what we have. So when we solve the three of them at the same time, what are we going to get? Remember, we said that when we have more than two resistors, we implement this formula. So let's quickly implement this formula and get what we got. So when we do that, we have that 1 over the arrow equivalent is equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and so on. So we have just three resistors, so we're going to have 1 over the equivalent resistor, which is equal to 1 over, let's use my arrow 1, just call it 12, plus 1 over, what's my arrow 2, is call it, let's say call it 6, plus 1 over the next one, 4. Please don't get me wrong. Remember, okay, let's just use arrow A, arrow B, and arrow C, so that we don't confuse it with what we've gotten here. So we just use arrow A. Arrow A is this resistor here, 12, arrow B 6, and then arrow C 4. So let's go started. So when we first thing that we're going to do is to find the LCM of these four resistances. So when we find the LCM, we have it that the LCM is simply going to be, let's say, just 12. I think so. It should be 12. So the LCM is 12. 12 into 12, we just have 1, plus 6 into 12, we have 2, plus 4 into 12, we have what? So 4 into 12, we just have 3. And when we push that up, we have 1 plus 2 plus 3, and that is 6 over what? 12. So we have that 1 over the equivalent resistance is simply 6 over 12. So if 1 over this is equal to this over this, so let's just take the inverse of both sides. We have it that the equivalent resistance is going to be 12 over 6. And when we divide this, we have our answer to be just 2 kilo ohms. So it simply means that the whole of these three resistors here, when summed up together, their equivalent resistance is just 2 kilo ohm resistor. So it simply implies that I can replace these whole resistors with just 2 kilo ohm resistors. So it now leaves us with what we have here. This is 2 kilo ohm. So this I can replace it with just a resistor like this, 2 kilo ohms. So you can see that this 2 kilo ohm is in series with this 2 kilo ohm. So I can simply add up. Finally, my equivalent resistance, which is the final equivalent resistance, final one. So it's going to be, so let's just call that final equivalent resistance as our ROT, RO total. So the total resistance, which the equivalent is going to be 2 plus 2. And that is what? 4 kilo ohm resistor. So we can just call it 2 kilo ohm plus 2 kilo ohm. That is 4 kilo ohm resistor. So this is the equivalent resistance that we are asked to find, which is the second problem that from the question. It simply implies that the whole of these resistors from here could be replaced with just 4 kilo ohm resistors. You saw the analysis how we were able to arrive at this 4 kilo ohm resistance. So to find the current flowing in the circuit could be very simple. Implementing Ohm's law, we can simply get the current flowing in the circuit, which is the second problem. With the first problem, we can say that the current flowing in the circuit is equal to the voltage over the resistance. So when we implement that, we have the voltage, which is 48 volts. We have 48 volts all over the equivalent resistance, which is 4. And when we punch that out on a calculator, we have the current to be equal to 48 over 4. That will give us 12 milliampere. Why is it milliampere? Because the resistance is in kilo ohms. Assuming that the resistance is in ohms, we're just going to have it to be 12 ampere. So because the resistance is in kilo ohms, we are going to have our answers in milliampere. So this is it for the current. Okay guys, that's gonna do for this video. We shall continue in our next video. Don't forget to subscribe and don't forget to give me a thumb up if you like the video. And do well to try out as many problems as you can see around you. Visit your textbooks, check out some questions online and keep yourself busy. Remember, practice makes one improve. So if you really want to improve when it comes to network circuits and some other problems, you need to keep practicing with questions, and that is going to help you to improve. So I will see you guys in the next video. Bye.